Alright, numbers of ways to traverse a graph. The problem here is that we want to given two positive integers representing the width and the length of a grid, a rectangular shaped graph. We want to write a function that returns the numbers of ways we can reach from the left top corner, which will be here, to the right left corner, right? So the ways we can think of it is going from the end. One algorithm will be saying, and the legal moves in order to reach from one side to the other ones are going to be either going down or going right, which means that one of the possible ways to go to here will be something like this, right? Or maybe something like this. So that's a possible way. So given that, we can think of different ways to reach S by studying the cases in which from the end, right? So from the end, we could only do something like this, like hook, and like that, right? And we calculate until it reaches what are the how many times it takes in order to reach S, and that's one of the ways we can do it. But it will be very inefficient because we want to in order to do that we have to calculate every possibility, right? So it will be something like 2n plus n being mn being the height and the width of this graph, right? And another way to solve this is we can say how many ways it takes us, or how many possible ways are there to reach certain square, certain grid. We can think of it like, so in order to reach here we can only have one way because you can only go right? Here too, one way. The same from the vertical zero index column, right? In every zero column of every row is going to be one way because you can only go down. It's not that you can do something like this, right? So you can do something like that because moving to the left is illegal. So knowing that, we can calculate the amount of ways to reach here, which should be always the amount of ways to get to the top and to the left, right? Which in this case will be 2, and then here it will be 3, right? Because now we have 3 ways to move here, and now we have 4 here, right? 3 plus 1, which will be 4, and that's the idea. So we calculate this for everyone, and so here you have something like 1 plus 2, 3 plus 3, 6, and the like, right? So that's going to be how we reach here, right? 10, something like that. Yeah, something like that. And the way, so now we want to calculate, now we want to create a program to do that. So here we have the program. First we create the grids on this first nested loop, and then we do these calculations over here. We see that if it's here in this line, in this code block, we have that if the height index, if the current width index or the height index is 1, then assign it as 1. Otherwise, assign it as the addition of the ways on the top and the ways on the left one, right? So let's write that in code. Let's go. All right, so how is that going to work? So first we want to create our matrix, right? So we say something like const ways equals like this, and we do, and we write we create a nested loop. Let I equals 0, I less than width, and I plus plus. I was a height first, and then for the j equals 0, j less than with j plus plus, and then we do ways, because we're just creating the thing. It will be the first one to create the thing, right? So here we have to create the row, because that's just one array. We can waste the push, and we can push the array into it, and then we assign the current ways. We push 0, right? Because at the moment we're just creating that matrix, that initial matrix for us to work with, and now we can actually copy paste this. Yeah, so first waste the push, we delete that, and here is where we are going to write our logic. If the case is that if I equals to 0, or j equals to 0, then what we do is that we say ways I j should be equals to 1, because there is only one way to get there. Other ways, we say that ways I j should be equals to -1. I'll just return that ways with my height -1 with -1. Let's see if this works. Yeah, let's see. I cannot read properties. And this happens on line 17, I think. Line 17, 0. Oh. Yes. Right. Okay. That makes sense. Right, so this works perfectly. Yeah, that will be it for this.